Okay. So, let's go ahead and get started. A couple announcements. The 5-3 homework online is due tomorrow. There was no written homework for that section. 5.4 I'll start today, finish it tomorrow. I don't think I'll need the whole class period to finish it, so I'll make some sort of worksheet or something that people can work on and practice for a while. Let's see, what other announcements? And then, yeah, the 5-4 homework will be due on Friday. Next week is going to be exam 2, so next week Friday, Thursday will be a review day. It's going to cover all the sections in chapter 5. What else? This Friday there will be a quiz on sections 5.2 and 5.3. That's what the homework that'll be turned in up to that point will be. Let's see. Anybody else have any questions or comments before we get started? We can do homework questions on section 5.3 tomorrow. Okay. So in the previous section, we solved 4 different types of triangles. I guess maybe one thing I can do is go back to the previous section real quick since I have the textbook open here. If it ever opens for me. There we go. Okay, so remember there's 6 different combinations. You're always going to be given 3 pieces of information, some combination of sides and angles. We handled side angle, so law of sines can be used to handle the side angle case, side angle, side angle. That was the weird one where you possibly have 0, 1, or 2 possible triangles. Today we're going to do side triangles. Okay, so you're going to be given an angle and then the 2 sides adjacent to that angle, and you have to find the other side and other 2 angles. We will also today be doing side, so you're given all the sides and you have to find the angles inside. And then again, I believe there is the case, or you know all 3 angles and you can find the sides as well. So today for law of cosines, so this is just another property that you can use to find the sides or angles in a triangle. We're just going to be looking at the side angle side case or the side. Okay, so you'll either know an angle and the 2 adjacent sides, or you'll know all 3 sides of the triangle. Okay. So first, I'm not going to go through the proof here, but if you like, let's see, did they actually do the proof in the book? So the trick here is, again, if I was going to derive law of cosines, which I'm not really going to, from this point B up here, you draw a perpendicular, that's the height of the triangle. And then this small side down here, you would use, I guess you can do cosine of alpha is adjacent over hypotenuse. That'll give you this distance right here. And then you can use the right triangle on the right to get the distance from this point to here. And then what you can do is, and again, I'm not going to go through the derivation unless anybody wants to. You can find it online all over the place if you just Google derivation of law of cosines. Okay, so I'm not really interested in deriving this, but let me blow this up for a second. So you all have this on your handout. Okay, so for any triangle whose sides and angles are labeled as above or in figure 5.3, so that's just your typical labeling scheme. Hold on, I'll come back down to this. Okay, so if you have a triangle labeled in either, so both of these are labeled the same, it's just the given information changes. Okay, so same labeling scheme, right? Whatever angle alpha is, the side opposite that is A. Whatever gamma is, the side opposite is C, and whatever angle beta is, the side opposite of that is lowercase b. Okay. And let me scroll back down so you guys can copy the formulas. And maybe I can make this just a tish bigger. Ooh, that cuts it off, so that doesn't work. Let me actually write these down. I think it'll be easier to see. So there's 3 laws, just like there's law of sines, you can set the ratio of sine of any angle over its opposite side equals sine of any other angle over its opposite side. Okay, there's 3 formulas for law of cosines, and I'll give you all 3 of them. Okay, so let me just draw the triangle one more time so we have it up here. So again, if I call that alpha and that's A, if I call this angle beta with opposite side B, and I'll call that gamma with opposite side C. Okay, now this is actually, law of cosines is kind of the analog of the Pythagorean theorem for right triangles. Okay. Now what law of cosines says is A squared, so this is the first formula, it's going to be the sum of the squares of the other two sides. Right? And that would be true for a right triangle. It just has to be adjusted for these oblique triangles. And then what you have to do is you have to subtract 2bc cosine of the angle opposite side A, which in this case would be alpha. Okay. So there's the first law of cosines. And you can either use it to solve for a side or solve for an angle. One thing I want to point out is if alpha is a 90-degree angle, so if this was a right triangle, anybody know what cosine of pi over 2 or 90 degrees is? 0. Right? So basically if alpha was already a right triangle, you would just get the Pythagorean theorem. A squared, the hypotenuse equals the sum of the squares. The square of the hypotenuse equals the sum of the squares of the other sides. Okay. So there's the first one. Okay. And then you have another one if you need to for the side B. So B squared is going to equal, and it's really similar, it's just the sum of the squares of the other two sides. So A squared plus C squared. And then you subtract twice the product of A and C. So again, I'm just using the other two sides. And then it's cosine of the angle that's opposite side B. So it'd be cosine beta. And then there's a third law of cosines. I suppose I should probably write that up here. And then the third one, anybody have a guess as to what it ought to be? Okay, so you need to sum the squares of the other two sides, so A squared plus B squared. And then what? I'm going to have to subtract twice the product of A and B. And then cosine of what angle? Yeah, right? The angle opposite side C is gamma. Okay. So there's kind of a nice, easy way to remember this. Right? The formula on the right-hand side involves the other two sides and the angle opposite C, okay, or the angle opposite the given side on the left. Okay, so there's three formulas, and just depending on what you're given, you use one of these three. Yeah. Oh. Anybody else need a handout? Did I miss anyone that came in?
There was, I got this one.
So this one. And Claire, I have a couple of homeworks for you. Okay. Now, does everybody have this little guideline sheet that I passed out? Notes on solving side angle side or side side side? Okay. So what it says is, if you're given side angle side, the first step would be using, so number one says use law of cosines to find the length of the third side. If you're solving a side-side-side triangle, you have to use law of cosines to find the first angle, but then after that you could use law of sines or law of cosines. So you'll be able to use the laws from the previous section when you're solving these as well. If you're solving side angle side or side 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 and you need to find a second angle, you might as well use law of cosines. There's one issue that arises. If you're ever going to use law of sines to calculate a second angle, make sure you only do it for the smaller possible angle. And then the fifth one, and I'll show you when we do an example. If you try to use law of sines to calculate a second angle and it's the largest angle, it might be obtuse. But notice that you'd have to use sine inverse, and the range of sine inverse is only minus pi over 2 to pi over 2. Okay, so if you ever try to use law of sines to solve for an obtuse angle, you're going to be in trouble. You have to fix it by doing 180 minus what you get, and I'll show you all in the example. Generally, the rule of thumb is use law of cosines whenever possible, and then you won't have any issues. But I'll show you when we do an example. All right. So example 1, we're going to do a side angle side case first. Now, none of these have, yeah.
I need this one, I think.
Okay. None of these ones that we're going to solve, there's only one possible triangle. Okay, so the only case where you have to be careful is the side-side angle that we did yesterday. Okay. So when you're given a side angle side or all three sides, there's only one possible triangle that works. Okay, so be careful. It's only the side-side angle case where when you're given some information, there's either no triangles, one triangle, or two triangles. Okay. So example 1, we're going to find the other sides and angles. So find alpha, beta, A. So find the side A, the angle beta, and the angle gamma for an oblique triangle where side length B has 3 units, side labeled C is 8 units, and the given angle alpha is 70 degrees. Okay, now I guess I already have the picture labeled over here on the left, but I'll redraw it again. I'm going to just draw an oblique triangle where it looks like all the angles are acute, but that's a misrepresentation in the case where one of our angles ends up being obtuse. Okay, so this is not necessarily going to look like our triangle, but let's just say the bottom left angle is alpha, that's 70 degrees. Okay, we need to find the side opposite that, labeled A. And again, this isn't going to be up to scale. If this is angle beta, this side's length 3. And if this is the angle gamma, its opposite side is 8. And let's see. Okay. So we're given 3 pieces of information. We need to find the other 3 pieces. Okay. So I'll break this down into steps. Step 1. So in the side angle, or what do we have? We actually have side angle side, right? SAS. So we have an angle and we have the 2 sides adjacent to that angle. Step 1 is going to be use law of cosines to find the length of the third side. Okay. So in the side angle side, you're always going to use law of cosines first to find the length of the third side. Now, which one of those 3 formulas for law of cosines would be most helpful here if we want to find the side labeled A?
First one.
Probably the first one, right? You wouldn't want to use either one of these two. Solving for A would be quite a bit of work because it's really a quadratic if you plug in all the other values. So we're going to use law of cosines 1. And in that case, we can just write this down. I can take the square root of both sides. So if I take the square root of both sides, I'll solve for A. We don't need a plus or minus because A is a positive quantity. And then now just plug in your known values, B, C, and alpha. So let's see, B was 3, so your first term under the radical is 3 squared. And then plus 8 squared minus 2 times 3 times 8. And then cosine of the given 70-degree angle. Okay. So again, I just took the square root of both sides here, and then underneath the radical, I plugged in all the given information. Okay. All right, and then if I brought my calculator. You get 7.52 if I do my typical 2 decimals? Okay. I'll just write down my implication here. Okay, so the third side is approximately 7.52 units. So now we have all the sides. Okay. And then if I need those, I'll write them up here again. But okay, so now I have all 3 sides. Now, here's generally what I do to avoid this thing with the obtuse angles. Okay, the only angle that could possibly be obtuse here is, well, which is the longest side? It's the one that's 8 units long. So gamma would be the largest angle. So I'm going to find the shortest angle first. Okay, generally that's what I do. Okay, so I'm going to find beta first. Now you can do it in either way. You can use law of sines or law of cosines. So step 2, I'm going to find the smaller angle using law of sines or law of cosines. Is it okay if I do both just so we make sure we get the same value either way? Okay. Okay, so I want to find beta. And we're going to do it in 2 ways. I think law of sines is technically easier to use. There's less work you have to do, but you can always use law of cosines. Okay, so I'll just do this. Let's do the law of cosines route first, since that's new. And then we'll try law of sines and make sure we get the same thing. Okay. So, if I want to solve for the angle beta using law of cosines, there's only one formula that has beta appearing. That's b squared is a squared plus c squared minus 2ac cosine of the angle, sorry, not gamma, but that should be beta. So again, the thing to remember is whatever side's being squared on the right side, you need the sum of the squares of the other 2 sides minus twice their product times cosine of the angle opposite this side b. Okay. Now we can plug in all the known values. Okay, so, and then what we'll do first is we'll solve for cosine beta. So I'll plug in everything I know, I'll solve for cosine beta, and then we'll convert to the inverse. Okay, so what do we know? We know A is 7.52. Is it okay? Well, you can do this either way. I think I'll just solve for cosine beta as is, and then plug everything in later. You can plug everything in before or plug it in at the end. So let's see, I think I would have to subtract the a squared and the c squared. So I'd get b squared minus a squared minus c squared equals the negative 2ac cosine beta. And then I can divide by minus 2ac. So I'll do that on both sides. So cosine beta then, since these cancel off, cosine beta is going to be, now typically I don't really like this form right here. It doesn't really matter. I can leave the negative in the denominator, or I could bring the negative into the numerator and distribute it through. Depends on what you want to do, but I'll just leave it as is then. And then when you're done, if cosine beta equals that value on the right, beta is going to be cosine inverse of that expression on the right, b squared minus a squared minus c squared over the minus 2ac. And then let's see, now our beta then is going to be cosine inverse, and then we'll plug all the known sides into the expression inside here. So you have a b squared, which is, so 3 squared minus the 7.52 squared minus 8 squared over negative 2 times AC. So that would be negative 2 times 8 times 7.52. So I would suggest you plug this into your calculator exactly as is. There are formulas in the book for this if you want to memorize them. I typically don't memorize, I just always resolve for the angle beta from scratch. But if you like the formula in the textbook, it rewrites this beta as cosine inverse of a squared plus c squared minus b squared over 2ac. So it just takes the negative in the denominator and multiplies every term in the numerator by negative 1. And yes, it is messy. Law of cosines is just kind of messy. That's the way it is. So let's see, 9 minus 7.52 squared minus 8 squared over, I guess we can do negative 16 times 7.52. Let's see, anybody get something yet?
22.08.
You get 08?
Oh, 1.
Yeah, I get 01.
I use law of sines.
Okay, well, we'll see what happens when we use law of sines. So law of cosines gave me 22.01. And I should probably write degrees. And then law of sines, I guess I'll have to erase this picture up here. Yeah, and your answer might be off slightly. Let's see what happens.
No, it's because you used 7.52 and I used 7.5.
Oh,
that's
okay.
the lie. I already figured it out.
Yeah, depending on how you round your values, it might change what your other values are. Okay. And then if you do law of sines, well, what can I set up with this relationship? If you're solving for beta, so you'll do sine beta over 3, you said, equals, okay, you can do sine, that's the only angle we knew was the 70 degrees, and now we know side A is 7.52. And then now you can multiply both sides by 3. Sine beta is going to be 3 sine 70 degrees over 7.52. And then beta is going to be sine inverse of this stuff on the right. So you can also use law of sines. And let's see. Second sine inverse fraction. Sure enough. Well, did I actually screw up rounding this one?
No, you didn't. That's what's confused. Because I got 22.02 and with law of sines.
Okay. Let me double check this one more time. There might be a slight discrepancy, but I'm going to ignore it, so whichever method you use is fine by me.
As long as the work makes sense.
As long as your work is logical. Huh. So they're actually off a little bit. They're not exactly the same. The hundredths place is off. But if you did round to, say, 1 decimal place, they would be the same. Okay. So, I think what I'll do is I'll just round to the nearest degree. So we'll just say that beta then, either way you do this, let's just say beta is just approximately 22 degrees. So they will be off slightly due to your rounding of the side A. But if we round to the nearest degree, they're the same. Which and then, so now what do we know? We know 2 of the angles in all 3 sides. Sorry, we know beta, not gamma. So now, how do we find the last angle, gamma?
180.
Yep. So we'll take 180 degrees and we'll subtract alpha and beta. And let's see, 180 minus 92, I think we should get, what, 88 degrees? Okay, so there will be a little bit of a discrepancy when you use law of sines or law of cosines. You can use either one. As long as your work is correct and every step makes sense, then I don't care which one you use. Although in this case, I think technically law of sines is a lot shorter and easier to use. And the law of cosines requires a lot more arithmetic and algebra work. And I think that's it. We were given 3 pieces of information. We needed the other 2 angles and the third side, and that does that one. Okay. So everybody okay there? All right. On the test, I'll probably just tell you to round your angles to the nearest degree. Okay. And then that'll get rid of the discrepancy when you use law of sines or law of cosines. Okay. All right. So I guess, yeah, step 1, find, if you have side angle side, find the third side first. And then step 2 is find the smaller angle to use the smaller angle, and you can use law of sines or law of cosines. Hopefully we get an oblique angle in the next one, or sorry, an obtuse angle. And then I can show you the problem in trying to use law of sines for the large angle. Okay. So example 2. So what am I given this time? It says find C, alpha, and beta. Where we have an oblique triangle where A has length 8, side B has length 3, and the given angle gamma is 20 degrees. Okay, so just to kind of help us out, again, there might be an obtuse angle in there, but I'm going to just draw it so that it looks like all 3 angles are acute. But it's just to help me understand what I know and what I need to find. So again, I can just kind of assume that all the angles are acute. It might not be the case. Okay, so the bottom right angle gamma is 20 degrees. And then the side opposite that is labeled C. The bottom left, let's just say that's alpha. The opposite side is A, which is 8. And then the side, or the angle beta can go on the top. And the side opposite that is B, which has length 3. Okay. So step 1 again, you're going to use law of cosines to find the third side. Okay. So let's see if we can write this down. Since the third side is labeled C, law of cosines that has C squared on the left is going to be most helpful. And what should I have on the right side? Okay, so a squared plus b squared minus twice the product a and b, and then cosine of what angle? Yeah, so what's the angle opposite side c? It's gamma. Okay, so that's law of cosines that you would want to use if you wanted to find side length c, or side labeled c. And then what I'll do is I'll just take the square root of the right-hand side and we'll plug in all these values. So it's the square root of 8 squared plus 3 squared minus 2 times 8 times 3, and then times cosine of that 20-degree angle. And we'll round it to 2 decimal places. Actually, let's just round it to 1 decimal place. That's fine. It just depends on what the directions say. Sometimes the directions will say 2, other times the directions will say 1. What'd you get there? If we're doing 1, it's just 5.3. Okay.
Yeah, it's 5.3.
Okay. So when you calculate that square root on the right and round to 1 decimal place, you get 5.3. Okay. So now we know this side is approximately 5.3. Now, I kind of want to see what happens first. So I'm just going to follow the same thing I did last time. Which angle is going to be smaller, alpha or beta? Okay, beta is going to be the smaller angle, right? So that means beta is going to be acute, right? There's only at most one obtuse angle in an oblique triangle. Okay, so I would recommend you just find beta first, and I'll show you if alpha ends up being obtuse, I'll show you the problem with using law of sines to find alpha. Okay, so let's just find the smaller angle beta first. Okay, and we can use law of sines or law of cosines, but what did we notice is probably easier? Yeah, so since it's easier, we'll use law of sines to find beta. And because this angle is going to be acute, there's no issue using law of sines. Again, the problem is if one of your angles is obtuse, using law of sines to find that angle is going to lead you to an angle that's less than 90 degrees, which is kind of an issue. Okay, so now what we can do is, if I want to solve for beta, so use law of sines to find the smaller angle beta. So we know sine beta over its opposite side 3. And then what do I have to use on the right? I can't really use sine alpha over A because we don't know alpha.
You use sine gamma over c.
So we have to use sine gamma 20 degrees over c. And then what does this tell us? This says sine beta then is 3 sine 20 degrees over 5.3. And then I can take sine inverse on both sides to get beta. And then what do we end up getting there? You get 11.2? Yeah, let's just round it to the nearest whole number of degrees, or the nearest degree. So beta is going to be approximately 11. Okay, so we got side C is approximately 5.3, beta is approximately 11 degrees. And then how do I find the last angle, alpha? Okay, so we'll start with 180 degrees, what all 3 sides add to, and we'll subtract the other 2 sides, the 11 degrees and the 20 degrees. So alpha then is 149. Okay. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149. 149 So it is obtuse, right? So does that make sense how my picture isn't really an accurate representation? I just used the picture though to help me kind of relate sides and angles. Now, let me show you the problem in trying to use law of sines and trying to find an obtuse angle. Here's what ends up happening. So and you could have, if you use law of cosines, there's never a problem. Okay, law of cosines will work to find angles every time, there's no issue. But if law of sines is used to find an obtuse angle, so let's just see what happens. So instead, what we could have done, instead of finding beta first, what if we would have tried to find alpha first? So there you would have known that sine of alpha over 8, so sine of the angle over its opposite side, would be sine of 20 degrees over, 5.3. So sine alpha would have been 8 sine 20 over 5.3. And then if you take sine inverse on both sides, by the way, from now on, you're probably not going to see me write arc cos, arc sine, or arc tan anymore, because it's just, to me, more writing, and it's a pain. I like to use the inverse notation. That's a personal preference. What do you get when you do this, though? Has anybody tried this yet? You get what?
31.7.
That's a problem, right? That's alpha is supposed to be the largest angle because it is opposite the longest side. Okay? So if you try to use law of sines to solve for an obtuse angle, what you need to do is you need to fix it. Alpha is really going to be 180 degrees minus its sine inverse. Remember when we solved second angles? You can use sine inverse to find the first angle. The second angle is always pi or 180 minus the first one. Okay, so, and if you do this, what's 180 minus that 31 point whatever? Yeah, if you approximate it to the nearest whole degree, this will now give you the 149 we had before. Okay. So if you know if you know an angle is supposed to be obtuse and you use law of sines to solve for it, whatever you get when you really have to adjust it. When you go to sign for alpha, you're not going to use sine inverse of this quantity. You're going to have to adjust it by doing 180 minus. Or, what can you do to make sure this never happens? Always find the smaller angle first. Okay? So that's another note you can add on your sheet that I gave you. So I would say note, always, so if using law of sines, always find the smaller angle first. Angle or angles first. Okay. Or you can use law of cosines all the time and it'll always work. How are we doing on time? We have 9 minutes left. Let's try and maybe squeeze a side in there. Like I said, tomorrow I'll make some sort of worksheet. I'll pass it out. People can work on it for a while. And then towards the end of class, we'll come together and just go through it. Okay. So now we'll do a side case. Example 3. So if find all angles if the sides are given by A equals 9, B equals 4, and C equals 7. So I'll draw the picture, but again, right, one of the angles might be obtuse, so this picture isn't necessarily accurate. So if this is alpha, this is going to be A equals 9. If this is beta, the bottom side is going to be b equals 4. And if the bottom right angle is gamma, the opposite side will be c equals 7. Okay. And again, my picture might not be accurate. I'm just drawing the picture to help me relate the sides and the angles. Okay, so what does guideline number 2 on my sheet say? If you're solving a side-side-side triangle, law of sines must be used to find the first angle. Okay, there's no way law of sines will work here. And notice if you tried to do law of sines, like if I wanted to solve for beta, sine of beta over 4 would equal sine gamma over 7. And then that would give you an expression where you have 2 missing values. Okay. So you can't use law of sines to find the first angle. Unfortunately, you have to use law of cosines. And it is messy. Okay, so let's see. And generally speaking, you probably want to find the smallest angle first. I'm just going to find beta first. So the law of cosines that involves beta it's beta squared equals a squared. Sorry, what did I screw up here? Yeah, we should have done c's. And then, like I said, you can solve for cosine beta. I'm just going to write this down. It's really a squared plus c squared minus b squared over 2ac. Alright, so if you solve for cosine beta, technically you'd be dividing by minus 2ac, but I pulled the negative to the top and distributed it through. And then the angle beta then is going to be cosine inverse of this whole expression. Yeah, we'll just round, for today we'll round to the nearest degree. Okay, be careful on your online homework. They might say 1/10 of a degree or 100th of a degree. Okay, so beta then is going to be cosine inverse, and then notice since in the inside that's just an expression involving all the sides a, b, and c. So what was our a? You're going to have 9 squared plus 7 squared plus 4 squared over 2 times a, which is 9, times c, which is 7.
Why did you add 4 squared but you subtracted b squared on top?
Oh, because you just caught me in a mistake. Where did I write that marker? Yeah, that should be a minus right there. Thanks, Ocean. Okay. And then anybody get this to the nearest degree yet? What'd you get? 25. Okay, see some other confirmations. So beta is 25 degrees. Okay, now the reason for this is I'm gonna do law of cosines again for one of the other angles. Why? Because if I use law of sines, I'm using an approximated value. But notice when you use law of cosines, a, b, and c, since those were given, those are all exact values. You're going to get a better approximation for your angle. So what I'm going to do is I'm going to kind of modify this formula. So this one right here, beta, notice, is the sides, so the side's not related to beta, so a squared plus c squared, and then you subtract b squared, and in the bottom you do 2ac. So say I wanted to solve for gamma, that's the next smallest angle. Gamma is going to be cosine inverse. Let's see if we can guess this just based on this. So I think it's going to be a squared plus b squared minus c squared. So you do the sum of the squares of the sides not related to gamma. Subtract c squared, and in the denominator you'll have the product 2ab. So that's what you would get if you took law of sines the law of cosines formula that involves gamma, and you solve for gamma. And then gamma is then going to equal cos inverse. This time it's going to be 9 squared plus 4 squared minus 7 squared over 2 times 9 times 4. What'd you get? 48? You get 48 degrees. Let me see what I have for time. We've got about a minute. So the other one's going to be 107. What'd you do to get that one?
I just subtracted.
Just did the subtract from 180?
I actually solved that one for science, so.
Okay.
Yeah, I used Law of Cosines wrong.
Okay. And then, yeah, alpha then is going to be 180 degrees minus the other two angles. And you said that was what?
107, yeah.
107? I guess technically it's an approximation.
I got 106.16 or something like that. 106.6.
Yeah, depending
Yeah,
on what you
106.6.
use and how you round, they might be 106.6.
Yeah, sorry.
Okay, so the nearest degree.
I just remembered it was 1 something.
All right, so again, tomorrow I'll put a worksheet together for practice. And then Friday there will be a quiz on 5.2 and 5.3. If you need anything else, just let me know. Homework is posted both online and written for this section. What's up? Oh, I must have missed it somehow.
I sent a PDF of it last night. So I
wonder if I accidentally turned off my connection to the internet.
I'll see you later.
I'll double check.
I thought I'd turn it in today. So you have
Alright.
2 copies now.
I thought I had something here for you. What's up, Tyler?
Can I get that take-home quiz?
Yeah, do you want to just give me a minute and then follow me downstairs?
Sure.